Hello, beautiful people. Welcome yet to another beautiful chemistry class. Whereby today we'll be looking at designing scientific investigation. And with me, Madalito July, chemistry tutor. So, our main objective today is to design scientific investigation. So, by the end of this lesson, we'll be able to design a scientific investigation. All right, let's dive into today's lesson. So, when talking of designing a scientific investigation, there are some facts that you have to know. So, you have to know that a scientific investigation is a systematic process of trying to find an answer or a solution to a problem or an observation. So, suppose you have an observation like when you take sugar, you put it in water, you try to stir, you see that the sugar disappears. Okay? Let's have a price with salt. When you take your salt and then you put it in water, you stir with using a stirring rod or maybe a spatula or a spoon, you see that the salt disappears. But then the question is, where does the sugar go? And on the same spot, you can take your paraffin and then you put salt in paraffin, you see that the salt is still there. Like just settle down. So find it at the bottom of your beaker or a cup if you're using a cup or a beaker, one of those. So the question is, why does the sugar dissolve in water, and then why does the salt dissolve in water, but it doesn't dissolve in paraffin or cyclohexane, something like that? So the question is, why is that the case? So that is an observation. Okay, so the question can lies from that observation. That's why I'm saying, okay, a scientific investigation should be a systematic process of trying to find an answer or solution to that observation. Why is that the case? Or else you may have a question. Okay. You have a question, for example, why does the rotten egg float and a fresh egg sink? Why? It's a question, that one. So you need to know, okay, why is that the case? Now, to that question, you need to now have a systematic process of how you can find an answer or solution to that question or that problem. You get it? So yeah. So yes, we want to design scientific investigation. But then before we design, we have to know the components of a scientific investigation. What is that we need? Remember, we said it's a process. Okay? Here we said it's a process. Now, being a process, it means that there are stages to be followed. Okay? Remember, a process has always some stages or some steps to be followed. So, yeah, what are some of the stages or components? Or components of the scientific investigation. So, the first component or the first stage of the process of scientific investigation is called problem identification. So first and foremost, you have to identify the problem. So yes, identifying a problem involves asking questions about the natural world. So for example, you can say, what causes rusting? Yeah, it can be maybe you left to, for example, bicycle outside your house accidentally, or maybe it might be a hole if you are into agriculture. You left your hole outside and then maybe it's raining. You come tomorrow morning, you find that there is that brownish coating to your hole, especially that iron part. So you wonder, why is this thing coming from? Or why is that my hole is having this iron coating? Why? Okay. And again, you can also have another question like, why do plastics not decompose easily? You take your plastic, maybe you bought something, and then the plastic you throw it away, and then you're using a hole, maybe you put what? Yeah, you try to dig somewhere on the ground, you put it under there. After some time, you are digging the same area. After a month or two, or maybe years, you find the same plastic there, like it's fresh. The question is, why do these plastics not decomposing? Why is that the case? So Questions like that, you first and foremost try to find the problem before we talk about the solution. All right. After that, you now have to formulate a hypothesis. So, what is a hypothesis in the first place? Hypothesis is a guessed answer to a problem. What do you think? Before conducting an experiment, you have to tell us your idea. What do you think? This one can be right or wrong. There's no problem with that because it's just your idea. All right. So, a hypothesis is formulated from the scientist's experience and knowledge. What do you know about it? Okay, after that, after hypothesis, then you do experimentation. That's where the real experiment occur. So you can choose to do it in the laboratory or everywhere which is feeling safe to do the experiment, because there's some experiments that need to be done in the chamber, others need to be done on the open space, others need to be done on the in the laboratory. So yeah, you choose, but then the experiment has to be conducted. So yeah, an experiment is a series of investigations intended to accept, modify, or reject a hypothesis. So using an experiment, that's where we do a series of investigation. We need to have the variables, independent, dependent, and control variables, and then we have to know that our investigation has to help us accept the hypothesis that we made in the first place, or it can help us what? Reject the hypothesis. Or it might be that you're not either right or wrong, but it needs to be modified. You understand what I'm saying, right? So yes, that's the experimentation. Apart from that, the fifth component or the fifth stage is about observation in that data correction. So this involves writing observation correctly, stating the correct units of each measurement. So it's now for observation. After conducting experiment, you leave the setup for some time. If it the need be, right? Yeah, then you need to correct data. You need to observe what you see. So data correction is now done through observation or through what? Feeding the container, whatever you can do. But then you can be doing measurements whatsoever. So it depends on the experiment. From one experiment to another, it depends. Okay. So you need to correct data through observation or another means. Now you need to write somewhere your observations correctly. And then you have to state correct units, because units matters most. Alright, so that when somebody wants to repeat the experiment, should know how to handle it, or should know where do you stop, and how do you record your results, and how can those results help or affect the results that he have to find. So yeah, you know the replication of experiment. So you need to know the result that this one got and then what you got. So yeah. Okay, so you need to present your data findings or your corrected data using tables. Okay, after correcting data, you need to interpret your data. So data interpretation means explaining the observation trends in relation to the aim of the experiment. So you have your results, you have your observations. Now you need to explain how are those results related to what you were aiming at in your experiment. How is that related to your aim of the experiment? Okay. Yeah, so finally we come to conclusion. So conclusion here is where you have to conclude. So what is the conclusion? So conclusion is is drawn based on the corrected data. So it is either confirmation or rejection of the hypothesis under investigation. So if the hypothesis is correct, it is confirmed and adopted, and if it's false, it is declared null and void, hence rejected. So when the hypothesis is rejected, another one is formulated and then tested. That is to say, when the hypothesis is rejected, you need to formulate another hypothesis. You get it, right? Alright, so if you have no question, then we call it a day for day. Yeah, and again, if you have any question, remember you leave your comment. You leave it in the comment section, and they'll be happy to help you out so that you understand exactly. Remember, during the exam, there'll be a question especially on the practical part, that you have to design an experiment based on whatever the manable people want to ask. So it might be that, or it be with the aid of a roll-level diagram describe why. So so you have to know how to design an experiment. That's why we had this topic. Okay, sure. So remember, if not chemistry, then what?